electric vehicles. So in this presentation, I have planned to give some overview about battery swapping technology, battery swapping stations, and control schemes of motor drives, and how to select the motor in their application based on their applications. Then we conclude that. So before starting that, we see that one or more slides regarding the evolution of the electric vehicle. So actually, the electric vehicle size market has been increased a lot nowadays. We are very well known about that. So actually, in USD market also, in 2030, 1.79 billion market size will be improved based on their forecasting periods. So actually, Chinese electrical market also, they have targeted about the 40% of the electric vehicles. So the electric vehicles, the importance have been enormously increased in the past few years, and also in futures also it will be increased more. So just few slides, the history has been started. Few slides we'll see that how the electric vehicles have been developed. So initially it started from mid of 19th century. Jetly Hungarian proposal have been implemented a basic electric vehicle with only the motor, because that time not battery was not implemented. The later on the battery technology has been implemented in the 1840. Then the small electric vehicles have been developed in 1899 with full electric vehicles. Actually, you are the first picture that electric vehicle completed 100 km/h. That is the first milestone about the EV in that period. So the lateral the development has been increased a lot. Even 1912 also purposely they have developed women electric cars in their countries. So these are very different scenarios. The vehicle has been increased, but after the First World War, only the electric vehicles scenario has been reduced. During that time, that time also they have implemented a small battery swapping technologies, charging stations. They have implemented in olden days. Later on, after 2000, the electric vehicle market is once again have been increased due to that the depletion about the IC engines and the environmental. So nowadays the Tesla Roadster car is somewhat very famous, because now the Tesla Roadster is also allowed that 0 to 400 km/h. So that type of things are there in Tesla Roadster, as well as there are different kind of automatic options are also have been implemented. So we can implement the electric vehicle in the different kind of applications. Now the hydrogen fuel cells also importantly presented, but rarely in our India, very minimum hydrogen charging stations are there. The remaining also we are implementing the electric vehicles in all kinds of applications. These are the different companies are mainly focusing about the EV, Nissan Leaf, BMW, Ford Focus, and Tesla. Yes, the different companies, they are using their different batteries implemented in the batteries, motor selection. So these are the things are there. So each companies, they are concentrating the motors. For example, one company, they are concentrating only inserting one motor or as a centralized motor. Some of the companies, they are introducing the one motor in the front side and another motor in the back side. So battery is commonly they are using. So this is the way each companies, they are giving some innovation in their product. This is a battery replacement in the buses. Just a pictorial representation. So this is a picture of buses, how the electric buses will be presented. There's another information. Actually, this is a world first 100% solar recharge electric transit bus. This is in Australia. This is powered by Zebra. They are using the sodium nickel chloride batteries with a rate of 261.8 kilowatts. So while considering the batteries, because we are going to see the battery swapping. So battery swapping in the sense, initially, at least we must know the some basic thing about the batteries, like SOC, SOH, and these are things are major part as a remaining useful life, our battery life estimation. So these are the things we need to consider viewing the batteries. So presently we are focusing lithium-ion batteries. So lithium ion is normally given as 160 kilometer per hour, but in future zinc, lithium sulfur, lithium air, and titanium dioxide. So this is the nanotubes, nanoparticles related batteries will be implemented in this one. But here, while talking about the batteries, so lithium-ion batteries are now we are using mostly, but at the same time we have to carefully use the lithium-ion batteries, because now in our mobile phone also now we consider the lithium-ion batteries. It is in a, but we have to use in the lithium-ion batteries in a very safe manner compared to that. But nickel, cadmium, nickel, metal hatred is not problem, but because we continuously monitoring the temperature also very important, because we had about so many news about that regarding the battery that explode fire explosion in the EV. So the problem is we have to carefully manage the battery management. Actually, in our battery also we are having the short circuit protector is there, small short circuit protector is there. So later on, if short circuit protector is failure in the sense, we may get a uh, chance of explosive. So that is the problem is there. So there are two important problems while considering the battery. So one is on one the problem is short circuit or occur, or sometimes if we put overcharging in the sense, that time also the problem is there. So we'll take care about the batteries. We'll take care about the batteries. We need to carefully cautious the short circuit as well as the overcharging. So if you concentrate these two in the sense, we can be carefully we can there is no problem occur in the while using the lithium ion batteries. But features we also go to that titanium oxide batteries. So normal lithium ion batteries provide that the 160 kilometer per hour. This is currently we are preferring. Okay. So while considering the batteries, we need to carefully consider this part: safe, power, capacity, light, large format, long life, and overcast. So because while you are going to swapping your batteries, so that time we need to take about the state of charge, state of health also very important, because you are exchanging your battery. So opposite persons also, opposite side of the batteries also, it should be managed the SOC and SOH. So that we will need to take it, because I have already told nowadays on lithium ion batteries only normally we use for swapping. So that time we have to carefully cautious about the SC protector, short circuit protector. So charging, we are preferring there are apart from that direct fleet customer charging, like direct electric vehicle to your charging station. We can prefer that wireless charging, like inductive coupling and capacity conductivity coupling or capacity coupling also we can be there. So it is a charging option is presented in that along the road along the roadside itself. So we are having the option for a ground level. That the two option is there. One is on in your vehicle as well as the ground side. So between that, the magnetic field is created. So one is the ground side, another one is on vehicle side. So between that, a magnetic field can be created. Based on that, we are using the inductive coupling charging. And capacitive or conductive coupling is also the same. So because here it can be produced some electric fields between the two plates. So based on this concept, we are using this. We don't want to wait a more amount of time in the sense we can go for these two kind of charging. But here, while charging these two, it will take around 20 minutes of time for wireless charging. Wireless charging. So only the battery swapping take as a perfect solution for to exchange your battery between two minutes, maximum 2 minutes. So inductive charging, there is no possibility of electrocution. There are no exposed conduct. There are no wired conductors is there. But we can feel very safe in that wireless charging systems. Only the ground fault detectors and vehicle positive parts. So between that, magnetic field can be created. Based on that, we can use for output charging systems. So we go for a battery swapping. So before going to the battery swapping, we must know about the SOC and SOS. SOC means you know very well, state of charge and the state of health. The state of charge means how much remaining life of battery you are presented, and state of health in the sense will start in terms of percentage, what is the present level, and while you are purchasing the first time, what is the charging. So that period is, we can tell as a SOH. So battery swapping station, there are the construction wise, there are different infrastructures are there. Some of the infrastructures automatically it's presented. Some of the battery swapping station is manually have been presented, but mostly automatically. Here in these pictures also, one of the things, maybe one of the architecture, one of the building, one of the box can be provided for swapping, and another one is for charging. So here normally the designing also, the designing of to insert of the battery also we need to consider. So normally the vehicle side, electric scooter na, we need only one battery. Suppose auto, rickshaw needs two batteries, electric rickshaw and electric auto needs three batteries. So based on that, we can give us a series connection. So here how we can be insert the batteries, since we can have some separate card is there. So like an ATM, so we can just put an the card, how much the empty, that is your drained battery option is immediately open, so you can fit your depletion batteries or drained batteries. So once it can be entirely then automatically it will be closed. Then once entirely checked, then the fully charged batteries will be open in the next slot. So based on that, we can easily replace the battery within 2 or 3 minutes. But normally if you take in the charging session, it will take around 2 to 3 hours it will take. That is a problem. So we have to swap the batteries in a very short duration of the time. So only battery swapping stations are highly important than the charging stations. So EV owner can swap the battery with the lowest state of charge to fully recharge battery within a few minutes. So normally time limit is fixed already. It will take 2 minutes, 2 minutes of the time. But here while implementing this battery swapping station, so we also carefully select the model. Like sometimes I need a battery. If we exchange your battery also, it will take around 100 kilometer, 160 kilometer per hour, because you are replacing the lithium ion battery. So normally it will take 160 kilometer per hour. So there are two options you can take: how much range you can be select, or how much charging period or charging time is required. So based on that, you select the batteries. You select the swapping option. So normally this swapping option is another advantage is we can improve the battery life. That is also another important, because we are charging the battery with the fully drain mode and as well as the fully charged batteries. So we can easily replace them. So battery lifetime is also very important here. So in futures also we are having some mobile app will be there, okay, because when one time you are swapping the battery, in the sense that is a data, so we can easily identify with the help of the apps where the nearby charging locations are there. Nowadays very few charging swapping stations are there. In that some other states they have already implemented, but they are developing in the same company names, okay, same company name, they have been developed, but it is a very the now present swapping station is very minimum in India. So we have to implement the large swapping stations. So here how we can be identified by using some app, we can be identify whether the nearby charging stations are there. Once you identify your nearby charging stations based on your availability of SOC, that all the details it will be displayed in the vehicle screen itself. What is the SOC of the battery, how much time we need to travel. So based on the analysis, we can identify where the nearby swapping stations are there. Then you can swap your batteries with your card. So there are so many options are there, like how we are using your credit card, GPay, same kind of things. Automatically the amount can be deducted, we can be pay, or otherwise some of the companies they are preferring like a toll gate, how their amount they are deducting. So we can use their card, then monthly wise they have taken the amount based on your ID. So this is the way we can use the battery swapping option in India. So if we compare the battery swapping to charging, then normally conventional EV chargers If you put on around 6 to 8 hours is needed. So in entire night we can put a charge. The next day only we can able to run. Nowadays, fast charging stations also implemented in our India. So there's so many stations are there, but the problem is even though a good vehicle conditions, battery is also very good, but it takes some time. 20 minutes of time is minimum required for a quick charging, fast charging. I'm telling about my bikes, okay. But battery swapping it takes a 2 minutes time. So based on that, we can be select. So only battery swappings are nowadays they are given us a more important. So actually, this concept has already implemented in 1896 itself. So in the pictures have given. So this is an commercially purchased trucks without a batteries. The problem is the GV company they are concentrating the batteries. This electric company is used to concentrated the only swapping the batteries. So here there are two companies. The standardizations we need to consider. Standardization, the ratings, as well as the space requirement in the vehicles, everything should be mapped, should be matched also. So that is a problem have been developed. But concept has been already implemented. But nowadays, for reducing the charging time, the purpose only now the battery swappings are enormously increasing. So here the problem of normal charging stations as well as the EV is battery degradation, long charging time. So these are two important issues. So battery also is very important here. So we need to continuously monitor the SOH of the battery. So life estimation also we need to analyze to use the batteries. So here the evolution of the battery swappings after 1994 is only has enormously increased because based on the availability of the charging. So only the inductive charging, capacitive charging. So they have been implemented. They have increased in a shortened period of time. So there are two options will be there for AC charging and DC charging. This is a different port based on the countries. There are different port of options are there. For example, in the pictures also, the Japan, America, they are using different kind of ports for charging of your the vehicles. So currently, swapping solutions is an enormously increase in India. So these companies are doing their some projects about the battery swapping alone. So battery smart, Sun Mobility, Govero, Volt smart swapping, and Esmito digital EV ecosystem. So these are the companies are they are concentrating more about the swapping session alone. So here evaluation about the battery swapping we'll see. Back here the swapping will be occurred 3 to 4 minutes itself by using the hydraulic stabilizer. But conventional EV vehicles also now IC engines market has been decreased nowadays. So we need to increase the lifetime. So lifetime about the EV in the sense we need vehicles in the sense we need a EV because we know that the cost of the petrol has been increases day by day. So we need a EV is a one of the option. So in the EV also we don't want to wait a more amount of time. So we need a swapping technologies. So actually in 2018 actually in Olympics also some of the Olympics also they use the around 500 buses they have used the swapping of the batteries in China. So later on, this is a history. So later on, the swapping importance of swappings have increased in the lot in the all the countries. So there are four different types of swapping we can provide it. One is an sideways swapping, bottom swappings, rear swapping, and the top swapping. So based on the selection of the vehicles, we can be provided. So sideways, bottom, rear wise, and the top swapping. Sideways. So for a vans or other vehicles, we can use the sideways position. This is a way the battery can be easily replaceable. So based on the vehicle's weight and the density, what are the ways the easy way is there? The swapping have been presented. So rear swap mostly car we have preferred the rear swapping. So bottom swapping is also there in the car. So but in particular a place the battery can be inserted and replaced. So here the option is first they have to replace the drained batteries, then he can fill up the chargeable batteries. So this is the way we can be swap the batteries. But here there is no manual operation, so we need to install the robotic arms. So robotic arms are placed here to move the batteries from the drained batteries to fully chargeable batteries. So top swapping is mainly used for buses, the electric buses. The batteries are normally here. Some of the buses are placed in the bottom side. Some of the batteries are placed in top side. So here the rooftop battery swappers are there by using robotic arms. They have taken completely and they have changed the batteries. So while in India also actually there are Honda swap technologies are there. So what there means they are using some smart card. Okay, we are providing some smart card. In the smart card itself, we can be track that. So how many times I have used the battery swapping, customers bad batteries, how many times SOC of the battery, and how much SOH is needed, state of charge is needed, and state of health of the batteries. So these are the things we can be easily done in India. So and also we can be pay based we can be based on the slots and based on the requirements. And also in the station also. Okay, this is the station. This is some pictures about the how the vehicles has been replaced their batteries. Battery compartment is there. So first you have to remove the depletion of the batteries. That is an automatic mechanical arms AMA. So the technology that robotic arms can be remove the depletion of the batteries from the EV. Then they can be charged then it go for a charging station. Then the depleted then you can replace by fully chargeable batteries by using the robotic arms. So charged batteries insert in the EV. The depletion batteries are put in the storage purpose. So once it has been properly confirmed, then the vehicles can uh, go from the position from the place. Here, the safety requirement also very important in the battery swapping. So the continuously in order to avoid the fire accidents or other things, uh, they are having the some continuous monitoring equipments like a temperature monitoring, load monitoring. So everything is presented in the battery swapping station itself. So some alarm is there for continuously monitoring the performance about the stations. And also based on the vehicle's arrangement, we can be select the number of batteries. So enter, unload, swapping, and exit. These are four options. There are four only processes are there. Okay, so actually in battery swapping session also we can integrate it to the grid for initially because only we are swapping the battery, but then the charging purpose we can be introduce the RE renewable energy sources also we can. So solar based charging sessions are there. So similarly we can propose a solar battery swapping session. Solar based battery swapping station is one of the good option. So these are some demerits they have provided. So on PHEV, plugged hybrid electric vehicle and plug electric vehicles discharge batteries are swapped with the fully charged batteries. So accordingly, we can use the swapping methodologies. Okay, so this is we have seen about some advantages about that battery swapping station. So because it is reduce the time, we can easily change the batteries. So apart from that, there are some technical aspects as well as the challenges also there. So one of the main challenges, very minimum swapping stations are there in our country. So we have to introduce the more swapping station. The battery slot also that should be a common one. So standardization is very less in India. Standardization is nothing but so we are using different kind of EV, different kind of vehicles, different kind of companies are there. So the standardization should be main common for all vehicles. like how we are using the petrol. We are using different kind of vehicles, but petrol we are using in the, we can go for any kind of petrol station. Similarly, the universal back slot should be provided for an all kind of vehicles. Only then we can easily identify where is the nearby charging stations are there. We can easily utilize. So that it takes some amount of time. These are the challenges are presented. So apart from that, we need to consider the energy management, location. Very minimum locations are there, so that we can use the app. Which one is on nearby locations are there in the battery swapping station, we have to identify. Then uh, train method is needed, okay, because it is fully automatically. But even though we only to fit that empty batteries, that is a drained batteries, that is also the awareness will be very less in India. So that swapping trained uh, method is needed to insert and to take the charged batteries. And also renewable energy integration with the BSS. So we can introduce solar based station is required, okay, because it's fully related to the energy. So we also introduce this renewable energy along with the battery charging station. The battery charging station and the swapping station should along with that, because sometimes battery swapping is not option is there, in the sense people can go for a battery charging station. Also, if any empty batteries are there, in the sense we can immediately charge the battery with the help of the charging station. So integration of swapping station and charging stations are required. So these are another technical aspect and challenges. Then optimization strategies for BSS. These are very minimum areas are the optimization strategies, because we can optimization way based on my load requirement, because based on, suppose my battery SOC level is 50% nearby, we have to identify where the nearby charging station or swapping stations are there, so that optimization strategies are very less. So we have to introduce some more optimization strategies to identify the uh, where nearby swapping and charging stations are there, charging or swapping, anyone. Then battery swapping techniques, very minimum techniques are there. That is also we need to take care. Then BSS EV scheduling. Scheduling is nothing but suppose you are thinking that you are riding your bike. Suppose you are having very minimum amount of batteries are there. So we have to see that nearby charging station, how many vehicles are there already waiting for a swapping, or how many charged batteries are there. So that scheduling options will be there, okay. Some of them regularly they are using their EV, like so regularly they give some slots, like every day the particular person use the swapping of the battery in the particular time. So there are different kind of opinions, or some emergency conditions also we can use the our vehicle for a charging. So the scheduling carefully we have to select. So like on 1 hour advancement, our daily schedule is there, or without any appointment also some people's they give their vehicle for a charging. So dynamic optimization, okay, dynamic analysis and the dynamic optimization is needed in the while implementing the battery swapping station. And another important one is a battery life. Battery life, because we are putting that empty charged batteries, and also you are going to get a fully charged batteries. So here, the battery life estimation is good. Battery life is very good in the battery swapping session, because we are fully drained battery to fully chargeable batteries, and we can continuously uh, use the batteries without overcharging. Because I have already told there are two issues in the batteries. One is a overcharging, another one is a short circuit. One separate short circuit protector is there in the batteries. So we can be easily identify that if any problem is there in the batteries. So these two we can continuously monitoring while using for a battery swapping station. So battery life also increase when using the battery swapping stations. Then charging strategies we can be introduced in the battery swapping station, because that charging strategy is inductive charging and capacitive charging. Sometimes if any higher number of persons are waiting for a swapping, in the sense we have to immediately charge your vehicle by using these two methodologies. So the road sideways we have to implement that. Will take 20 to the 20 maximum 20 to 30 minutes for inductive or conductivity charging. So based on the, yeah, we have already told, we will have some separate card is there for accessing these kind of things. So we can easily visualize how much SOC of the batteries in a screen. The screen itself we can be easily visualized. So these are the options, different opinion, different options are there to using the battery swapping station. Also, we need to consider these points like energy management, integration, optimization techniques, and scheduling. These four are problems. All these four problems also we need to consider while using the battery swapping station. Next one is we have to consider the battery life. Battery life in the sense battery life estimation, battery the forecasting period. Everything we need to consider. If any batteries are highly drained or it is not battery life is very less, in the sense we will not share the batteries to the customer. Okay, so that is also we need to calculate. Apart from the SOC, remaining useful life REL also we need to calculate. Next one is aggregator. So what is it? These are aggregator in the sense aggregator is a common person for a vehicle to swapping. Okay, because we need some third person is needed for this communication. So we are using some app, we are having one card for a payment, and then we can able to access the how much SOC of the battery. So our entire data which has been fed to the swapping station. Once we inserted the card, our entire data which has been data can be stored. So we can easily predict that when it will be charged, when your charging will be over, they can be easily predicted. So a common person is needed for all kind of these. And also I need if I need to charge my vehicle within 30 minutes. So I need to see that which one is nearby. So what are the shops? What are the charging stations are there in nearby? Also, I need to swap the battery without any waiting of the time, because already some vehicles are there, are not. How much batteries they are already having? So everything I need to monitor within the place itself. So aggregator is needed. So that is an BA is aggregator. Like it's a common the communication between the vehicle owner to the swapping owner. So that is a BAS aggregator. So it will be an fully communication oriented. This is a central hub for battery swapping station. It can identify that availability as well as the scheduling, how much scheduling swapping times. Okay, or booking and payment and location. These are the things. So we can use a mobile app also. That is also aggregator for a communication between these two things. Is the architecture. So first one, Y is nothing but EV owner, X is nothing but the charging stations. So even the drained batteries are there. The drained batteries should be go for a charging. Okay. So here empty, we just put a empty battery and we can get a fully chargeable battery like V and U is shown in the picture. And also we can connect it to the grid, to the utility grid, to our swapping stations. Also actually inductive charging and capacity charging already we have discussed. So in that time also we can give us a high, suppose you are having highly chargeable highly chargeable batteries. That time also you can give to the grid by using the dischargeables. Okay, it's not only the charging base. Suppose you are having the highest amount of charges, you can also connect it to, you can connect it to the grid. So the vehicle to grid options also there in chargings. So BSS modes, there are three important modes are there. First is single BSS, battery swapping station. So here the method is very simple. So suppose we are having the very minimum amount of charge, I need to charge my batteries. So dynamic, this method is called dynamic methodology. For example, I am having already 70 percentage charge. I need only 30 percentage is enough for a fully drained battery, for a fully charged. Suppose I'm having 0 percentage batteries, so I need to have a 100 percentage fully chargeable battery is needed. So don't put the batteries with the 0 percentage. So sometimes I may put as a 0% or 10%, or sometimes I put a 50%. So your the calculation is there. So where you are, where are you staying, and how many distance battery swapping stations are there. So it should be a calculated one. In charging station, how many vehicles are there. So now you, after reaching your station, how many charge you needed. So everything we calculated and based on the curve. So this is a single BSS mode. So just I reach the swapping station. What is the available of the my empty batteries, empty swapped batteries, and a fully charged battery. You can take a fully charged batteries. Okay. So inside of the station, swapping station is also charging stations will be there. Based on the availability of your slot, you can charging your batteries. Suppose you are having 50%, 50% of battery has been immediately charged and they will be replaced immediately. So this is a battery single mode BSS mode. So here the option is immediately they can charge your batteries and they possible to give, or already fully charged batteries are in the sense they can be immediately replaced. So immediately replace our swapping battery and immediately uh, replace the fully charged batteries. So this is a single BSS mode. So in single BSS mode only one communication so between the vehicle owner to swapping stations. So between one aggregator is there. That's all. This is a battery swapping station, single BSS mode. So here this is a multi BSS mode. So multiple BSS mode in the sense both here swapping different swapping stations are there. Sometimes I am using my vehicle for swapping 1 hour before, or a daily regularly routine work I will swap the batteries, or emergency purpose. The three cases are there. In the three cases also the control center, that is our aggregator, has to be communicate properly, and they have been sharing the network, sharing the swapping station. Suppose they can be tell, so this is your battery status, this is the time you have came for swapping station, and this is the time is required for swapping the battery. Everything we can tell to the customer between with the help of the control center. So based on that, customer can accept or reject. So that option is also there, because nearby different swapping stations are in the sense the customer can prefer that station. So that level of communication should be there based on this within this control center. So therefore, so for example, in the BASS one, so suppose BASS one in the sense the charging batteries are two port is only available, two slots only available. So they are allowing only two vehicles for charging the batteries. So in second station, entirely all charging stations are full. So entire all 9 slots have been full. So they go for a swapping station 3. So this is the way. Once your batteries can be replaced, immediately it go for a charging mode. So this kind of communication should be given to the customer. Then customer can accept or reject. So that option is also there in the battery swapping station. And last one is integration of these two. What is these two in the sense? Battery swapping and battery charging stations. So battery swapping in the sense based on the availability. Sometimes while riding the car, we may take some time. We may take some time for rest. Also, battery also have been trying. So that time we can decide that whether you go for a charging battery or swapping the battery. Sometimes a battery swapping station, there are more number of vehicles are there, your battery is also very minimum, so that time we can be select for a charging mode. Now fast charges have been implemented, it will take around 20 minutes of the time. So based on the availability of the slot, you can be selected. So this is the one good method. So we have to introduce both for swapping as well as the charging station. Okay, so based on our requirement, for we can give the option for swapping or charging, or only swapping or only charging. So based on the control center, it had been based on the availability of the center, available of the slot, control center can communicate to the customer. Then we can select, we go for a charging or swapping. We have any time in the sense we go for a charging, or we can go for a swapping. So based on the availability of the time as well as the vehicle allotment, we can decide it. So this is the third mode, BSS and the BCS integration. And compared to the previous two modes, this method is a very good method. So robotic methodologies are used for the swapping of the batteries, and also we can introducing to renewable energy systems in the charging station. But everything we need to communicate, because if we're introducing the energy management strategy also, we need to consider. So battery management system. So normally your battery should not go for a more than 45 degrees Celsius. 25 to 40 is a normal operating range. So we need to continuously monitor the battery's temperature. If we go more than 45 degrees Celsius in the sense, it may chance to the explosive. So battery management systems are highly recommended in the battery swapping station. And also method cooling introduced for batteries. Normally we cautiously maintain the 25 to 40 degrees Celsius temperature. This is the way of providing the energy from vehicle to home and the vehicle and grid to vehicles. So battery management system is there. Battery monitoring, like we continuous monitor SOC and SOH. Battery optimization also, we need to introduce the battery swapping stations. This is an universal pack slot, UBB, universal battery pack slot, because here we can in future we can also share your batteries to the customer without involving the swapping station. Suppose we are riding we are riding in the road. Suppose we are having very minimum amount of battery. That time the same kind of batteries any nearby any persons are them, you can easily swap the batteries, because we are going to swap the batteries. We don't want any aggregator. So that time, if you want to share your battery without any third person or aggregator, we need a universal back slot. So common slot should be provided based on the availability of the country. Common slot should be provided to insert the batteries. So common slot in the sense there is no use. We can easily swap the batteries at the any kind of companies. So that is the standardization should be improved. That is a UBB, universal battery pack slot. So common slot for each batteries. That is the redesign have been developing. So while sharing station in the sense, it can be you're sharing. We need a IoT, telecommunication and communication interface, AI for a charging. So for forecasting the battery time forecasting, everything we can be come to the battery sharing stations. It's a battery sharing station. So how many battery packs are there? So they are sharing based on the availability. So AI based concepts are highly needed for these battery sharing stations. So network is also a common universal battery pack architecture is there in the sense we can communicate to the management system how many vehicles are there, how many time I need to wait for swapping my batteries. Okay, then if I having excess battery in the sense I can provide it to the grid. So this kind of thing also we can be introduced in the battery sharing network. Is nothing but I am having the highest amount of charge. I can connect it to the grid. So this is the way also the sharing network is working. Also here in India, EV policies are there for battery swapping alone. There are around 80 to 100 policies already there. So I just consulted some important policies in the battery swapping. So first one is unique identification UAN. So UAN is common UAN number is needed for swapping of the battery, because there are different kind of customers are there. So we need to track our battery strategies. Okay, sometimes I am buying very new battery. Okay, so I am just exchanging out the batteries in the battery swapping. I got a very old batteries, but it having 100%. So normally I am hesitating to get my old batteries, okay, instead of the new batteries. So this problem may be occur. So UAN number, common UAN number should be needed for a EV batteries. Okay, so we can track, we can monitor that where our batteries are there. Then battery management system, testing and certification for our battery swapping components are there. So they are having maintenance, some standards are there. Separate certificate they need to produce while implementing this battery swapping. So now they are having some plan 1 to 2 years for metropolitan cities. They plan to implement 4 million swapping, and immediately for major cities they can be implemented as a second way, two-wheeler and three-wheeler vehicles in their plan to implement the battery swapping station. So these are some policies we are having for EV battery swapping. Fixed batteries, swappable batteries. These are some conditions will be there. Based on that, we can swap your batteries. Then public PSS, public BCS. Okay, only swappable batteries for a public usage purpose. So this policy is already mainly implemented for reuse and recycle of your batteries, and business models also there. Okay, well, challenges in the sense there are so much challenges is there in the battery swapping. First one is interchangeability, feasibility, infrastructure, battery degradation, and battery ownership. Interchangeability in the sense, suppose um, the interchangeability of the battery pack in a different manufacturers. So that is the problem is that. So that's it, that we have already give a solution. It should be an universal battery pack slot, so we can easily change the battery with any kind of companies. So that is the first option. But these are the problems, challenges is there in the presently. Feasibility is we have to install the batteries in a small kind of vehicles. Okay, for example, we may go for 100 to 300 to 400 kilometers, but available the vehicles that kind of battery we cannot provide it. So small amount of batteries only they have been provided. They can insert in the vehicles. Normally, scooter na two battery slot only we can be provided. Based on that only we can be use the your vehicles. In auto na we can put three. So only very few feasibility design will be there. So that is also another hurdle. Infrastructure. So while you install the battery swapping, it will take a more amount of cost than the charging station. So cost is also very high. So very minimum state only they are implementing this battery swapping in their particular state. Some cities they are implementing near 10 to 15 battery swapping station. So the infrastructure is very high here. Battery degradation, this is also one problem. So the degradation uh, continuously monitor. You should be continuously monitored, because I am giving you a fresh battery, but I am receiving the very degradable battery, in the sense that is not good. So we need to continuously monitor the what is the lifetime about the battery, what is SOH. So the same kind of SOH we have to give to the next customer. So that time the problem will not come. But the battery lifetime we need to calculate it. So the degradation problem will be also there. On particular time battery degradation will be there. So this problem should be another issues in while implementing. Last one is ownership. So ownership in the sense, normally we will not give us a fresh battery. So there are two batteries. There are two slots are there in your vehicle. So we have to buy only one battery for primary purpose. Then you can use for exchange purpose. You can use another battery. This is the only option is there. Otherwise, the ownership problem will be occur. So these are things. Next, small within time, I'll take 5 minutes for a vector control method. So in vehicle selection, now battery is over. Next one is a motor selection. So motor, we can be fit a model. Different kind of motors are there. We know that BLDC, PMSM, induction motor, and also different control methods are there. Normally, we can use the brushed DC motor is also there, because brushed DC motor there is no any controllers are presented. But nowadays EV we will not use the brushed DC motor. So we use for we will use the brushless DC motor, because there is no brushes and no commutator is there. Why brushless DC motor is highly preferred now? Because we need a high amount of torque to ride a vehicle. So we need a BLDC, and also high starting torque, efficiency also good in the BLDC. So normally BLDC is preferable. Then nowadays PMSM also they are using. So PMSM is mainly used for high torque and low speed applications. We can use the PMSM. Electric car bus also prefer. Each company they are using their motor in a different purpose, but the characteristics are there. So PMSM also they can be used for a highest amount of torque. Then another one is induction motor. Tesla preferring induction motor only. But we'll go for this induction motor in the sense for a maximum torque generation, we need some control method like a field oriented control or a director control method are needed. So here induction motor is a perfect choice for a because low cost and low maintenance, long life also. And also the problem is we need to introduce some inverter circuit in the drive spot. Then SRM drive is there, permanent magnetism there. Permanent SRM we are used for a high speed application. High speed here also inverter circuit is needed. High power density we can also is presented. So these are the some drives characteristics. So based on your requirement, we can be select the different kind of motors. So this is the rating about the drives here. So if we see in the sense induction motor drive PMLDAC based on the efficiency, weight, cost, they put some mark. But DC motor drive is not useful in the EV side. So it is not implementing very low kind of speed applications. We can use DC motor, but normally we are avoiding. So this very minimum kind of applications we use for a brushless DC motor. But control method in the sense we need a variable speed or variable torque. So that purpose is needed. And also some of the company they are introducing the vehicle slot in the single motor option or dual motor option. So single motor also we can be put as a single main motor has been connected in the vehicle. So dual motor in the sense they give an option for front side two motors and rear side two motors, or only one motors for front side, only one motor for back side. So there are different kind of modes of operations are there. So centralized single motor and multi-motor drives also we can present it. But the control method is there are different control methods are there. So but the option is which option you are going to select, whether the torque or speed. So torque now we can use for a DTC, and speed now we can use for a FOC, field oriented control methodologies they are using. So important method is there are three important methods. One is a P by F method, voltage by frequency, then IFOC and DTC. So here most open loop conditions we go for a V by F method. IFOC is mainly used for a dynamic torque control as well as the speed control also. DTC mainly for speed torque control methodology. But dynamic control operation, sometimes I need to ride a vehicle higher speed, sometimes I need for a lower speed as well as the high torque. So there are different combinations are there. So that dynamic conditions we can go for a DTC method. So normal V by F control methodology. But we here mainly industries are preferring the vector control method because we are going to control indirectly control your torque and flux of the machine, flux or speed of the machines by using the principle. So here mainly this is mainly for to generate a dynamic torque. So there are two options there. Here also you consider the BLDC drive vehicles will be there. So I need a highest amount of torque. So I need a 3-phase inverters is required for IFOC and DTC. So we need a 6 switches. So we need a PWM pulses. So continuously monitor the current values based on the adjustment of your regulators. We can generate your signals in the PWM signals. Is mainly for a higher torque applications. And DTC method also we can be used for a torque control application. Sometimes I need a highest amount of torque in our vehicle, so we can use for a DTC method. So here the difference is switching transients. We can select the switching pulses in a very easy way when compared to your IFOC method. We can use this method for all kinds of drive, BLDC, PMSM, and induction motor drive. We can be used. This is the way they are selecting the switching vectors, the 6 switching pulses. These are the switching sectors S1 to S6. Based on the availability, we can be based on the selection of vectors, the switching pulses can be generated. So based on the flux, torque, the corresponding voltage sector has been selected in the DTC. These methods are mainly required for to generate the torque in the vehicles. This is some sample research just I have provided for an understanding purpose. Current component, stator current value, 3 phases in a sinusoidal waveform. Here you just see now the reference value is accurately tracking the your actual value in the TTC. Here some ripples are there, but we can be easily reduce the ripples. Torque repulsion technique is there. You can easily reduce. Also, you just see the waveform about the torque speed. So accurately match your reference speed. So this is the way we can be prefer the DTC control methodology in the industry drives application as well as the EV side also. So next one is we can introduce these training methodology like ANN, ML. We can machine learning. We can be introduced here. There are two options will be there, whether you are going to forecast or online generation system. So online now, the vehicle running condition itself, you are analyzing dynamically adjust your control signal. That is the online training. Offline trainings now prediction, future prediction, so that we can use that what is our SOC of the battery, how much time my vehicle has been run in a smooth way. This future prediction we can use for a machine learning application. That is also whether you are going for a classification or regression problem. So this is the way we can be introduce the neural network and machine learning slowly in our vehicle side. So here just for online training, I put an ANN, and instead of PI controller, normally we are preferring, we just replace the PI into ANN. In the ANN also, whether you for offline training or online training. So online training, there are plenty of equations are there. We can create a model in the training in the system to adjust the control variables, and we can be accurately track your torque of the vehicles, torque and the speed of the vehicles. So like torque ripples we are facing, so we can use a ANN instead of PA. We can use for a ANN for a accurate torque tracking application. So there are plenty of options are there. We can use that AI methodologies to in our electric vehicle side in a in different way. So main thing we can use for a prediction forecasting applications we can use, or ANN is used for a controlling your speed and torque application. You can remove the conventional PA controller and you can replace it. It's a direct generated model is there, and Adaline extraction model is there, so we can directly write a equation, we create a model, and we can be remove the PA controller to this process. So we have seen two topics. One is a battery swapping, another one is a drive system. So research opportunities are there in battery is sharing network. Battery sharing network is there. We can introduce the IoT and the AI methodologies for interaction to the grid. Then forecasting by using machine learning, we can using for forecasting about the battery swapping, because there are the forecasting about the battery swap is a very fresh area. The very minimum papers are there. In the battery swapping also very minimum papers are there. The forecasting or energy management, the automated scheduling of the battery swapping, this is very minimum papers are there. So these are the things we can be taken as a consideration in the battery swapping, and also cost benefit analysis for the sharing network, because we can immediately share your batteries to your neighbor, your unknown person, in the sense how much benefit analysis we need to consider. Then also thermal management analysis, SOS prediction, remaining useful life prediction. So these are the some research opportunities are there in the battery swapping and battery management system in the electric vehicle side. In the drives also, it is on these kind of applications we can use that sensorless drives. So here we have discussed about a conventional 3 types of machine with the sensor drive. Sensorless motor drive we can be estimated. Instead of we are giving the standard reference speed, we can use for a sensorless estimation scheme. Observer schemes also there. So that methodology also we can be introduced. The same I have already told. You can use the machine learning and deep learning ANN for a forecasting application, like how much the lifetime of your machine, fault detection, fault tolerant drives you can be designed in this drives area. So we can easily estimate the loss. Mainly fault applications of the drives also we can be included in these research opportunities. So in the conclusion, so we have seen two topics. One is for battery swapping and the DTC method. So battery swapping, the approach we have discussed for mainly for reducing your charging time. and also in futures we may so many battery swapping stations will be there uh, for that. So futurely how much we can use the app for battery swapping. So much research opportunities there in the battery swapping stations.